So let's say we have our graph of our lab data in front of us, and in our experiment we took Alka-Seltzer and dropped it in glasses of water with the water at different temperatures. Temperature is down here on the x-axis, so that was our independent variable. It's a factor we're trying to see if it has an effect. We want to see if it has an effect on the amount of time it takes for the Alka-Seltzer to completely bubble, to react. Now what we can see with the graph is that when we start in the beginning part, where our temperatures are the coldest, 10, 20, 30 degrees Celsius, that the time was the highest. When we get down to the end, at temperature 70 and 80 degrees, that the time is at the lowest. You can see that the data points line up pretty much on a curved line. And what that tells us, that gives us an idea that there's a relationship between temperature and time. To summarize that relationship, I would say that as temperature increases, as we go from left to right on the graph, as temperature increases, the time decreases. Now let's say our lab data turned out a little bit differently. Let's say at 10 degrees we had a time of about 24, 23 seconds, but then at 20 degrees Celsius the time dropped all the way to 7 or 8 seconds. Then at 30 degrees the time went back up, then came back down again, and then later on went back up again. If we get a pattern where our data points kind of line up, where it keeps going up, down, up, down, up, down, what that's basically telling us is that our variables have no relationship between each other. Or in other words, the temperature of that water had nothing to do with how long, how much time it took for the Alka-Seltzer to react with the water.